disaccharide because now we have already completed monosaccharides and their reactions. Now you can have an ability to identify monosaccharide, right? Identify the structure of monosaccharide if I give the molecular formula of the monosaccharide, right? Now you know what are the important reactions of monosaccharides you can use to identify them, right? So last time we discussed that. Today we are going to start the new section that is about the disaccharide. So disaccharides actually not like monosaccharide, they are combination of the monomers. That means at least two monomers. Right? Two monomers join together to form one disaccharide. Right? Monosaccharide only monomers, like a same. Right? But disaccharide, two those monomers join together to form one unit of disaccharide. When it forms, right, that means when one monosaccharide joins with another, right? So we can observe, right, the releasement of water molecule from them. When the bond form, one water molecule releases, right? The bond between two monosaccharides are identified as glycosidic linkage. It's the word glycosidic. Glycosidic linkage or glycosidic bond, right? So this linkage can be alpha or beta. Now you know what is alpha beta. This linkage can be alpha or beta. That means if the bond between two monosaccharides, if we take monosaccharide like this, right, and the other monosaccharide like this, right? If these two join together like this, H, OH, OH, right, like this, right? So what will happen? One water molecule, right? One water molecule released from this bond, right? But if you take this hydroxyl group, this is at the beta position. I think you know what is alpha, what is beta, right? This hydroxyl group at the beta position, right? This is not the way. OH. So if I draw very clearly, I think it's not clear. You take two monosaccharide like this. Right? If you draw the hydroxyl group positions of the monosaccharide like this, right? And so this, with respect to this molecule, this hydroxyl group is a beta. Sorry, alpha. Right? But this hydroxyl group is a beta. Right? This hydroxyl group is a beta. Right? Therefore, if we think about this one and this one, right? Won't go to the upper way, right? like this. Therefore, our logic is valid for this kind of bonds identified as beta bonds. Right? In other case, sometimes this is hydrogen, but this is hydrogen. Now the bond releasement of this 2O. Now the bond like this. Bond like this. This is alpha. Right. So that means the bond can be alpha or beta when it forms disaccharide, depending on the reactive groups, positions of the reactive group, right? Right. Then we can categorize the glycosidic linkage between two monosaccharides, right? Alpha and beta, right? If it is go upwards like this is beta type bond, right? Downward like this is alpha. So anyway, we have to think like this: two monosaccharides join together through glycosidic linkage by releasing water molecule to form one disaccharide. So this is the deal. This is the deal. That glycosidic linkage you can further classify whether it is alpha or beta, depending on the type of positions of the hydroxyl group of the monosaccharides. Right? That is very, very clear point. Right? Then we will think about what are the examples for this kind of disaccharides. Right? So, very famous examples are sucrose. I think you know what is sucrose. What are the responsible monosaccharides available in sucrose? Right. Then maltose. Right. Then lactose. Then trehalose. These are the two examples for disaccharide. Right. So if we take sucrose, what are the monomers? For sucrose, monomers are responsible monomers are fructose and glucose. Responsible monomers are fructose and glucose. So these are the two monomers of the sucrose molecule. Right. So out of these two, right, based on your memory, can you tell me, can you think about this? Right? What are the differences and similarities of these molecules? Both molecules are 6-membered. That means both molecules contain 6 carbon atoms. Right? But one molecule is the aldehyde sugar, but other molecule is the keto sugar. Therefore, carbonyl carbon of these compounds, if you think about the position of the carbonyl carbon, in case of glucose, this is at the terminal position as aldehyde. But in case of fructose, that is not like that. Right? It is in the middle position. So when glucose join with fructose, which carbons interact? That is very important thing. Right? Glucose join with fructose, which carbon atoms are going to be interacts in both molecules. Right? So if you remember the glucose molecule, right? Very simply, if you draw the molecule, it is like this. We take alpha 1, it's like this. This is the glucose. This is glucose. But if you try to draw the fructose, this is like this. So we can't use the common hexagonal form. Why? Although it's six-membered system, right? Although it's six-membered system, the carbonyl carbon available at the second position. Therefore, in this case, formation of sucrose, first carbonyl carbon joined with the second carbonyl carbon of the fructose. First carbonyl carbon of the glucose joined with the hydroxyl group attached to the second carbonyl carbon of the fructose. So that means that glycosidic linkage is 1, 2, 1 and 2. Now there is a very interesting story. Right? Very interesting story when we think about sucrose, because sucrose is very important sugar. Why? That is stable sugar. And it is very common sweet available in the world. Right? Therefore, we have to know so many things about the sucrose and their biochemistry. Right? So if we think about the sucrose molecule, right? So bond behavior like 1-2 linkage, glycosidic linkage. Therefore, then if we think what is 1, what is 2, very clearly if we think what is 1 and what is 2, 1 is the carbon responsible for the carbonyl carbon of the right glucose molecule. This carbonyl carbon. Right. The 2 is the responsible carbonyl carbon, right, of the fructose molecule. Right. Not like other molecules that you take 2 glucose molecules join together to form maltose like this. Sometimes bond may be 1-4. That means if the first carbon of the carbonyl compound, that is glucose, interact with the fourth carbon of the other glucose molecule, right? That means linkage is 1-4. Therefore, now you can observe different structure. But here, you can observe very important structure formation, right? Both carbonyl carbons of the compounds join together through linkage. That is very important here. Right? So I will draw the bond formation for your information like this. Very clear. Right? So if we take glucose molecule like this, H, OH, OH, H. This is the glucose molecule. Right? Then I am trying to draw the structure of the fructose molecule. OH, CH2OH. This is the fructose molecule. Right? Now we think about the bond. Bond like this. Formation of glycosidic linkage by removing whatever. Right? So bond like this. So therefore we can think about this bond, right, as alpha glycosidic bond. Right? So carbon number 1, 2, 3, 4, 5, 6. Right? Again, if you try to number this one, 1, 2, 3, 4, 5, and 6. Right? Now you can clearly observe that bond between first carbon of the glucose and the second carbon of the fructose. Right? So that is the nature of the sucrose. Right? Then if we think about other example, right? Again, we draw the structure for the glucose, same one, like this, OH. CH2OH. This is the another molecule of glucose. Right? In addition to the sucrose, now we are going to discuss another structure, disaccharide. Right? Then I will try to draw another glucose molecule like this. Now two glucose molecule. So these two glucose molecules interact like this. And removal of water molecule. Again, bond like this kind of bond, or between these two glucose units, right? Glycosidic linkage, yeah, that is alpha glycosidic linkage again, right? Alpha glycosidic linkage. Then removal of water molecule, two glucose unit. Carbon numbers, if you check, is 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4. Forget about this last part. 5 and 6. Now you can observe again bond between 1. Right? This molecule is known as maltose. Right? The molecule is known as maltose. This is maltose. This is sucrose. So what is the difference between sucrose and maltose? In case of sucrose, bond between 1, 2 alpha linkage. In both compounds, they contain alpha linkage. In case of maltose or sucrose, both are in this position with respect to these molecules, positions have sometimes maybe beta, depending on the position of the hydroxyl group. Because this is alpha isomer. Right? If we consider alpha isomer, right, we can consider this bond like alpha bond. Right? But what is the difference? The difference is Difference is here first carbon of the glucose joined with the second carbon of the fructose. First carbon of the glucose means actually when we discuss our monosaccharides, we explain, right? First carbon of the glucose is a carbon in carbon. That is anomeric carbon. So that time I explained the special name for that carbon, anomeric. Anomeric carbon. Right? Anomeric carbon. Right. So in glucose, position of the anomeric carbon is the first one. But fructose, if you check the structure after large or long corona vacation, right? Sometimes, okay, right? You may forget about the structures of the fructose glucose like this, right? Please go through the notes and check, right? What are the positions of anomeric carbons of those compounds, right? Anomeric carbon means carbonyl carbons, the same name, right? Right. The anomeric carbon position of the fructose is the position 2. For the glucose is the position 1. So bond between 1 and 2 means both anomeric carbons are in the same bond. But in case of maltose, second example, maltose, anomeric carbon is first one for the glucose, this molecule. This is again glucose. Therefore, anomeric carbon is the first one. But there is a speciality. What is the speciality? Speciality is here bond between 1 and 4. First carbon of the 1 glucose molecule join with the fourth carbon of the second glucose molecule. First carbon of the 1 molecule join with the fourth carbon of the second molecule. That means bond between 1 and 4. 1-4 linkage. 1-4 linkage means there is the availability of free anomeric carbon. That is very important theoretical point in this structure. That's what I need to explain. That's why I use both examples in the same place. Right? In this case, right, 2 anomeric carbons available in 2 compounds, but both are in 1 bond. There are no free anomeric carbons available in this. Right? Remember, that is very important. No free anomeric carbon available in the sucrose as a disaccharide. But as a monomer, fructose contains anomeric carbon, glucose contains anomeric carbon. But in case of sucrose, that is a disaccharide. That is not a single molecule. Therefore, you cannot observe any anomeric carbons availability in the sucrose. But if you take maltose, the case is different. Case is different because now you can observe 1 anomeric carbon, 1 free anomeric carbon. Both are anomeric carbon, but 1 anomeric carbon engage in 1 bond. Engage in 1 bond. That is, bond is a 1-4. Therefore, 1 anomeric carbon engage in this bond. Therefore, only 1 free anomeric carbon available in the bond. Sorry, in the system. Right? Remember, that is very important point. Then I will draw the next structure. Next structure. See this one. Again, I am going to draw the 2 glucose molecule. But this time, story is a little bit different. One molecule draw like this. The second molecule draw like this. Rotate the molecule. Right? Then HOH. HOH. Others are same. Because these two carbons are important in formation of bond. Right? When considering the glycosidic linkage, these two carbons are important. Right? This is number 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Now, what is the difference between these two? In this case, is a maltose, first carbon of the glucose joined with the fourth carbon of the second glucose through glycosidic linkage, right? That is one pole linkage, right? Because of that, product is the maltose, right? In that product, in that molecular structure, you can observe one free anomeric carbon because only one anomeric carbon engage in the glycosidic linkage. But here, case is totally different. First carbon of the first glucose unit interact with first carbon of the second glucose. Because this is another rotation, not the same one. Right? Another one. Right? First carbon of the glucose unit join with the first carbon of the second glucose unit. What can you say about the freedom of the anomeric carbons? Are there any free anomeric carbons? No more free anomeric carbons. Why? Both free anomeric carbons engage within this glycosidic bond. If the bond between 1,1 type, right? No free anomeric carbon engage. Sorry, no free anomeric carbon available in the compound. Both are engaged. Linkage is 1,1, right? Depending on the orientation, you can say this is again alpha linkage, right? This kind of linkage, alpha linkage, right? Alpha glycosidic linkage, but the carbon positions are 1,1 linkage, therefore no free anomeric carbon, right? So this compound is known as trihalose. 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 So trihalose means again monomers are same monomers as maltose, but the bond formation is different. Now you can observe. Sometimes if anyone asks question, monomers available in fructose. Sorry, sucrose. Then you can say glucose and fructose. Then he may ask monomers available in maltose. Then you can say glucose and glucose. Right? Then again he may ask monomers available in trihalose. Then glucose and glucose again. What is the difference? Different is the bond formation. Right? Now you can observe, depending on the form of the bond, total property of the sugar can be changed. That is the interesting point of the biochemistry. Depending on the form of the bond, positions of the bond, total property of those compounds can be changed. So what? Then we will see what are the important property based on this bond, based on this information. Right? Now you may heard very simple terms in your O levels sometimes or A levels chemistry, right? Two simple terms. So they are reducing sugar and non-reducing sugar. Reducing sugar and non-reducing sugar. So sometimes you may heard about in Sinhala, but English terms also very familiar to most of the students. reducing and non-reducing. So how do you select those properties with respect to their structures? Right. So if I ask any non-reducing sugar example, right, you may directly use the answer sucrose. Right. If I ask reducing sugar, you may directly give the answer maltose. But if I ask a question like this, can you give two examples of reducing sugars or non-reducing sugars? For the reducing sugars, you can give two examples, lactose, maltose, like there are common reducing sugars. But non-reducing sugar, your famous one is a sucrose. So this is the another example, trehalose. Because trehalose is again non-reducing sugar. Because how do you define reducing or non-reducing capacity of the sugar, disaccharide? Right? First, we have to think about the availability of free carbonyl carbon or free anomeric carbon. Very simply say. If you very simply say, we have to think about free anomeric carbon or free carbonyl carbon available in the compound. First, we have to think about that. Without engaging any bond, if there is a free carbonyl carbon within the system, now you can categorize that compound, that kind of sugars are reducing sugars. If there are no free carbonyl carbon or free anomeric carbon available in the system, right, you can categorize those sugars are non-reducing sugars. Right? So based on that, sucrose is a non-reducing sugar. First carbon of the glucose joined with the second carbon of the fructose, both anomeric carbons engage in the bond. Therefore, this is non-reducing sugar. Right? In case of maltose, first carbon of the glucose joined with the fourth carbon of the glucose, linkage between 1,4. Therefore, one free carbonyl carbon or anomeric carbon available. Therefore, maltose is a reducing sugar. Right? In the third example, if you come with the first carbon of the glucose joined with the first carbon of the second glucose, now both carbon of the anomeric carbons of the glucose engage within the bond. Right? Therefore, no free anomeric carbons within the system. Therefore, we can categorize trehalose as a non-reducing sugar. Now you can identify what are the reducing, what are the non-reducing sugars. Right? So if we take the structure of the lactose, the basic components are glucose and galactose. Right? But the bond between 1,4, first carbon of the glucose joined with the fourth carbon of the galactose. Again, galactose is a 6-membered system, aldo sugar, right? Aldehyde group at the terminal position like glucose, right? First carbon of the glucose means this one, right? In case of galactose, again, first carbon is the carbonyl carbon, but in the case of lactose, first carbon of the glucose joined with the fourth carbon of the galactose. Fourth carbon means this kind of carbon. Right? That means linkage again like same as the maltose like linkage, but only difference is this one is galactose. In that case, this is glucose, this one is galactose. Right? Therefore, we can think about lactose as a reducing sugar, right? Same as the maltose. So we can explain the thing same as the maltose, right? There is a one free anomeric carbon available in the system. Therefore, we can say lactose as reducing sugar. Right? I think that is very clear. Now you can identify the structures of reducing and non-reducing sugars. Right? Then we will discuss few examples of disaccharides. First, we have the very famous examples, maltose. So what is maltose? So we discuss the structure of the maltose, right? It consists of two glucose units joined together through 1,4-glycosidic linkage, 1,4-glycosidic linkage, that is reducing sugar. Right? So you can produce maltose in the degradation process of starch. That means starch is a polysaccharide, consists of glucose unit, large molecule. When you degrade the starch by using enzymes or different chemicals, when you degrade the molecule, break down the molecule into small components, right? Then you can produce two molecular units, two disaccharide units, and smallest unit, that is maltose. So generally maltose we can use to improve the sweetening capacity of the system because it is easily soluble compared to starch. Right? Easily soluble. Easily soluble means rapidly soluble because it contains high amount of hydroxyl group. Not like starch, that is very rapidly soluble one. Right? In most of the cases, we use maltose as a good ingredient. Right? Then we will think about the second example, sucrose, very famous one. Right? Sucrose is a famous sweetening agent. That is again disaccharide. That is not like maltose. That is a non-reducing sugar. Right? Basic components we have already discussed, fructose and glucose. Right? 1,2 linkage between two molecules. Right? Therefore, that is the non-reducing sugar. Right? But when you break sucrose molecule by using enzyme or dilute acid, you can use enzyme invertase or dilute hydrochloric acid. When you break this glycosidic linkage, what are the products? So products are fructose and glucose. When you break this glycosidic linkage, right, by using enzyme invertase or dilute hydrochloric acid, what are the products? So products are glucose and fructose. So glucose and fructose are the major products. What can you think about their reducing capacity? Both are reducing. Why? All are monomers. All the monosaccharides are reducing sugars because all the monosaccharides contain free anomeric carbons. All have reducing capacity. Right? So that kind of questions are very important because when we ask questions, we are not going to directly ask, right, from the theory. Right? You have to apply the theory in the certain system. That is the learning. That is learning. Right? Right. Then, if we think about this sucrose one, sucrose, when you use dilute HCl or enzyme invertase, one of these systems, when we use dilute HCl, hydrochloric acid, or enzyme invertase, products are fructose plus glucose. Right? Products are fructose plus glucose. Then, before I go into the next explanation, I would like to explain very simply about the specific rotation. I think when you learn stereochemistry in your chemistry lectures, sometimes you may learn, right, stereochemistry. In that lecture series, you may learn about the specific rotation. This is the term. Specific rotation. Specific rotation. What is specific rotation? Specific rotation means very simple thing. We can explain very simply, but by using specific rotation of the molecule, you can say so many information of the molecule and molecular behaviors. Right? It is like this. Right? So if we think about the solution, you think this is sugar solution. Then if you expose this sugar solution to the plain polarized light beam, I think you know what is plain polarized light. Plain polarized light. Right? So if you expose the sugar solution to the plain polarized light beam, plain polarized light beam, plain polarized light beam. So plain polarized mean, I think you know what is plain polarized. All the atoms, light particles, not atom actual, light particles move up and down, no, left, right, right, same plane. Movements are in the same plane, right? Not like this, here and there, right? This the same plane. So that kind of light beams you can prepare using different techniques, right? Normal light like this, in a different ways. Light particles move in different ways, right? Normal light, but plain polarized light beam not like that. You have to prepare the plain polarized light beam through filters, specific techniques. Now you can convert the beam like this. Now in this beam, special type beam, particle movement in the same plane, plain polarized. Then we are going to expose sugar solution to the plain polarized light beam, right? So sugar solution contains certain number of molecules. Sugar solution, if you think about, if you assume this sugar solution contains 50 units, 50 molecules, 50 atoms. So, sorry, not the atom, 50 molecules. Right? Then, after passing this one, because of these sugar solutions, right, this direction of the light beam can be changed, can be either this way or this way. Right? Because of the sugar solution, after passing this sugar solution, the other part of the light path can be changed, right? Depending on the sugar solution, right? If you think like this, right? This you can observe as a result of all sugar solution, that is all 50 molecules, right? All 50 molecules responsible for this direction change. Or if you think about this part, all 50 molecules responsible for the direction change. Right? But if you think about what is the contribution of one molecule, if you think about contribution of one molecule for this direction change, that is the direction change per molecule. Direction change per molecule. So that is known as specific rotation. Right? That is known as specific rotation. When we explain specific rotation, we have to explain it like this within this kind of brackets, right? Degrees we have to mention, and very important point, the temperature. When we express the specific rotation of the molecule, we have to specially use the degrees of specific rotation with the temperature. Because depending on the temperature, specific rotation can be changed. Right? So we cannot fix the specific rotation value for the specific molecules. Same molecule can show different specific rotations in the different environment. Right? I think now you get the point of the specific rotation. What is specific rotation, right? So when you expose 50 sugar molecules, sugar solution containing 50 molecules, that is sumption. No need to further think about that, right? How do we count number of molecules available in the system? That is for the explanation, right? If we assume that system contains 50 molecules, if we expose plane polarized light beam to that system, right? Then because of this sugar solution, the direction of the plane polarized light beam can be changed. The amount of the change, the rotation angle due to whole number of molecules, impact of whole number of molecules. Right? Therefore, we can say because of the 50 molecules of sugar, we can observe change of the direction. Then we can calculate if we think about this capacity per molecule. If we calculate, so that if we think this rotation is 60 rotation by 50 molecule, then we can calculate what is per molecule. Per molecule 1.2. If the case like this, specific rotation in this solution is 1.2. Right? Per molecule capacity. Right? Now that is specific rotation. Based on this explanation, now I will give specific rotation for the normal condition in the sucrose solution is plus 66.5 degrees. The normal room temperature condition. Specific rotation for the sucrose is plus 66. Right? That is like this. Plus 66. Right? So if we take pure fructose, that is fructose, if we take fructose, and glucose. Pure form of fructose, specific rotation is minus 92.2 degrees at room temperature. At room temperature, minus 92.2. And pure form of glucose, plus 52.7. Right? Pure form of fructose, specific rotation. Now you know what is specific rotation, right? Pure form of fructose, specific rotation is minus 92.2 degrees. Pure form of glucose, specific rotation is plus 52.7 degrees. Pure form of sucrose, plus 66.5 degrees. Right? Now, if we think like this, at the room temperature, if you break the linkage of the sucrose into fructose and glucose, like this, right? So, because of the specific rotations, we don't think about the amount available in the system, right? If you calculate anything per molecule, then you can get the idea about the molecule. Right? Per molecule, you can get the idea about the molecule. Then we have to think about specific rotation of the sucrose like this. Then fructose, now you can write minus 92.3. Glucose plus 52.7. Right? Any questions? Right? 52.7 degrees, 92.2 degrees. That is plus, this is minus, this is plus. Now my question is, what is the final rotation of the final product? Because when you break this into two groups, you cannot observe like this part fructose, this part glucose. You cannot expect like this, separately available. All these in the same mixture again. Same mixture, fructose plus glucose. Freely available. Same mixture. Right? Therefore, so my question is, what is the orientation of final mixture? Initial orientation of sucrose is the plus 66.5. Specific rotation. Right? Then initial fructose specific rotation actually minus 92 point. So we can expect the same fructose available here. Therefore, we can think at the room temperature, fructose can rotate by this amount. Right? Then glucose. The normal condition, the room temperature condition, glucose can rotate the system like beam by this amount, 52.7 plus. Therefore, that is specific rotation. We can use that value. Right? We don't think about the how many fructose molecules are there, how many glucose molecules are there, because we just think about the negative and positive particles. Right? Then plus 66.5. This side minus product minus 92 and plus 52. What do you think about the final orientation? Plus or minus? Please think with little bit before I tell that one. What do you think about the orientation of the final solution? Specific rotation, not orientation. Specific rotation of the final solution. Now the solution contains fructose and glucose mixture. You can't say that is fructose, that is glucose separate. That is within the mixture. In the mixture, you can have both molecules distribute here and there. Right? So what is the specific, or maybe the specific rotation, negative or positive, at least you can think. This is very simple. Negative positive calculation, right? This side positive because of plus 6. But if you come to the side of the equation, plus 52 minus 92. Forget about 0.2 and 0.7. Plus 52 minus 92. What is the answer? That is grade 7 mathematics. Right? 40. But 40 means negative, not the positive. Right? Now, this side of the equation, positive, but this side of the equation, negative. Right? Positive form convert into negative form. Right? This is known as inversion. See the term. Inversion. When positive form convert into negative form, positive form convert into negative form, that is known as inversion. Inversion. Inversion means the orientation totally 100% convert into another form. Positive convert into negative form. Right? So if you think about the stereochemistry, that is very interesting. So when you go with the umbrella, right, and the very windy day, right, if the winds is very high, what will happen to the umbrella? Right? Upside down, it converts. Upside down by the wind. Right? Upside down by the wind. Side of the umbrella convert to the downside. Right? The same things happen in the stereo forms of these reactions. Right? If you think about stereochemistry, same things. That's why we name these are inversion. Completely. Therefore, products are named as invert sugar. Products are named as invert sugar. So fructose and glucose are invert sugars with respect to the hydrolysis of sucrose. With respect to the hydrolysis of sucrose, fructose and glucose are invert sugars. Right? I think we have enough explanation based on the invert sugar and specific rotation. All are based on the chemistry, right? But when you learn something in here, it's very important in your future, because when you think about any system, you can use this knowledge to explain that system, right? Chemical behavior of the system, right? Then we will think about the next example, that is lactose. This is again another disaccharide available in the food system. Lactose available as a major carbohydrate in the food material. Very famous one, that is milk. Right? Major carbohydrate available in milk is lactose. That is disaccharide. Right? Major carbohydrate available in milk is lactose. That is disaccharide. Right? So when we discuss the disaccharide example, I explain the structure of the lactose. Lactose consists of galactose and glucose. Right? First carbon of the glucose joined with the fourth carbon of the galactose. That means bond between 1 and 4. First carbon of the glucose joined with the fourth carbon of the galactose. That means bond between 1 and 4. Bond between 1 and 4. Bond between 1 and 4 means there is a availability of free carbonyl carbon or free anomeric carbon in the galactose unit. Right? There is availability of free anomeric carbon in the galactose unit. Right? Therefore, we can consider that disaccharide, that is galactose, lactose, as a reducing sugar. We can categorize lactose as the reducing sugar. Okay. Now you think about like this. That's why I have already said, right? When you explain certain situations, you have to use this knowledge. So if you think about diabetes mellitus-like condition, diabetic mellitus-like condition. So people may say, if you are suffering from diabetes mellitus, right? If you consume large quantities of milk, consume large quantities of milk, it can be dangerous. Why? People sometimes, although they are suffering from diabetes mellitus, people sometimes use sugar in the milk. In addition to the milk, they add sugar to the milk. Sometimes they may say very little amount of sugar, like this. Right? Sometimes some people may say we can add little amount of tea, black tea, along with the milk. Right? And we can add small amount of sugar, like this. So these are the logic of them. But if they explain any logic, the real logic within the system like this, milk contains lactose. Lactose is a major carbohydrate that is reducing sugar. If the reducing sugar available in the food material, it can be responsible for the increasement of your blood sugar level. Therefore, hereafter, think about that. If you consume more milk, it means you may give indirect support to increase your blood sugar level because it is not like tea. Tea does not contain that kind of carbohydrate. But milk contains lactose as a carbohydrate. Right? Therefore, if any person who is suffering from diabetes-like condition do not consume large quantities of milk, especially milk with sugar. Milk with sugar, because sugar is again when you consume sugar, it's converted into glucose and fructose within our digestive system, right? Then the reducing capacity double. Right? Therefore, lactose is dangerous for them. So, what do you think, right, as a remedy for this problem? If you are suffering from diabetes mellitus, that is very dangerous cumulative disease, right? So, what is the remedy? So, remedy is if you can ferment this sugar, this disaccharide. That means if you ferment lactose into lactic acid, by fermentation you can convert lactose into lactic acid. Lactose into lactic acid. Right? Then you can minimize the dangerous condition. You can minimize. Why? Now there are no lactic lactose. There is a lactic acid. Lactic acid cannot increase your blood sugar level. Therefore, instead of consuming fresh milk, right, you have to advise them to consume fermented dairy products. Fermented dairy products, because those dairy products contain lactic acid, not the lactic acid. To give this kind of advice, you have to need this knowledge. What is the available major carbohydrate? So what are the properties of that molecule? Whether it is reducing or non-reducing. If it is reducing, what are the good properties? What are the bad properties? Right? Not for all. For healthy persons, right? They should not worry about this one. Why? For healthy persons, they don't worry about this one. Why? They don't worry about the increasement of blood sugar level. Right? Their insulin amount enough to control it. Right? But in case of diabetic condition, right, they have to think about this. They have to think about this lactose. Right? Therefore, you can advise to them to consume lactic acid contained food, that means fermented dairy products rather than fresh one. Right? That means rather than ice cream, better to eat yogurt and curd, right? Right? That is the very important thing, fermented thing. Rather than ice cream, better to consume cheese. Right? Cheese-like products. Fermented dairy products. These are the secured, right? That is the important point of lactose. The second important point, right? Sometimes some persons cannot digest lactose within their digestive system. Sometimes some persons cannot digest lactose within their digestive system. That is very sad condition of the human, right? Not for all, but there may be some cases. From their infant stage, they cannot consume lactose containing food. From their infant stage, not the adult stage. Right? From their infant stage, there is an insufficient amount of responsible enzyme, lactase. Responsible enzyme is a lactase. You need lactase as enzymes to digest the lactose. If it is very low in the system, digestive system, your digestive system cannot digest lactose. So what will happen? If your digestive system cannot digest the lactose, right? Sometimes certain microorganisms available within your system, they can digest and they will produce unwanted gases within the stomach. Right? So the microbes interact with lactose, they use lactose as their food, those microbes, right? Then they produce unwanted gases as byproducts. Because of those gases, there is a condition formed named as flatulence. Flatulence. Right? Because of these gases, flatulence condition can be happened. Flatulence condition. Flatulence can be butter begin. That is the condition of flatulence. Gases available in the stomach without food. Right? That is sometimes dangerous. Not good condition, especially for the infant. Especially for the infant. Right? So if the infant faces this condition, it can be, right, lead for the death. Right? Therefore, this is very dangerous. Other one is when he or she become adult with this lactose indigestible nature, right? At the adult stage, again, they cannot digest lactose. Condition is same. Right? Therefore, there are certain allergic reactions can be happen. Vomiting, bashing, color change of the skin, right? Different things. Right? That is certain allergic reactions can be happen when they consume lactose containing food. So that condition is known as lactose intolerance. Lactose intolerance. Lactose intolerance. So they cannot tolerate lactose within the system. They cannot tolerate the lactose within the system. Therefore, the condition is known as lactose intolerance. Lactose intolerance. Right? So for the answer, what is the answer for this kind of person? Again, answer for this kind of person, fermented dairy product. In case of fermented dairy products, they don't worry about the consumption. Why? It does not contain lactose. It contains lactic acid. It contains lactic acid. They don't worry about the lactose. Therefore, they can easily consume fermented milk product instead of fresh one like ice cream. Right? They cannot consume ice cream. Even sometimes biscuit, because biscuit ingredient, one of the ingredients are milk. Therefore, sometimes they cannot consume biscuit also. Right? So that is very important point of the lactose. The next important point of the lactose is, right? Lactose is very sweet. Taste-wise, it is very sweet compared to that sugar, that is sucrose. Why? Compared to sucrose, lactose is very sweet. That means it is more sweeter than the sucrose. Then there is a question again. If it is more sweeter than sucrose, why do you add sugar to the milk? That is a small question. Can anyone give the answer? Think about the answer. Right? If the theory like this, lactose is more sweeter than sugar. Oh, lactose is sweeter than sugar. Right? So, when you consume milk, because milk is a major carbohydrate, high amount of lactose available in the milk. So, when you consume the milk, why do you add sugar? It has already there, that means lactose. More sweet with more sweetening capacity. What is the reason? Can you think about it? I think FSC students can give the answer. Because they have already followed dairy part in their first semester. Right? In my dairy lectures, I explained. But FSC students, unfortunately, right, they cannot obtain that chance. Right? But they will obtain the chance in their third year dairy technology lecture series. Yeah. At that lecture series, I think they will explain that responsible lecturer will explain the chemistry of the lactose. I think she will explain it. Right? But in this fact, I am going to explain the sweetening capacity. Actually, theory like this. Right? Lactose is sweeter than the sucrose. That is very true. But if you take lactose within the milk. Lactose within the milk, you cannot obtain the same capacity, same sweetening capacity. So that means if you take lactose in free form without milk, as a lactose as a sugar, very sweetening agent, more sweet. But within the milk, that sweetening capacity is masked by milk protein casein. Within the milk, the sweetening capacity of lactose is masked by casein. This one. Casein masks the sweetening capacity of lactose. So what will happen? Finally, sweetening capacity of lactose gradually decreases. So that's why we need to add sugar to the milk. Right? So this time I think you may have online exam, right? Because of this COVID problems, right? If we organize online exams, sometimes, right, oral type questions can be there. Oral type questions can be there, right? And in the case of oral type questions, so these type of questions are very common. Why? I am not going to ask, draw the structure of glucose. Draw and show me. I am not going to ask like that. Right? So this kind of knowledge is very important. If the lactose show more sweetening behavior compared to the glucose, sucrose, right? Why do you add sucrose to the milk when you consume it? So you have to explain it. That is the biochemistry behavior. Biochemical behavior. We have to explain. That is very important point. So that kind of forms can be there. Right? Therefore, if you have any system, please use this knowledge. Right? In this degree, we expect application of the knowledge. Right? Not followers. Right? You have to practice this knowledge in day-to-day activities, day-to-day questions. How to solve the day-to-day question. So if you discuss so many people, they have so many problems with so many foods. They may ask, is this good for this kind of thing? Right? I am suffering from this kind of disease. Is this food good for it? Right? But you can't say medicines. You cannot prescribe medicines and Ayurvedic treatments, anything. But you cannot prescribe suitable food. You are the persons for that. You are the persons for that. To do it, please thoroughly think about chemistry behind those things. Right? Otherwise, you cannot tell it. You cannot tell anything. Right? If you know the chemistry behind everything, right, you can very clearly explain the system. Right? So, like a lactose and milk. Right? Right? That is the next important point. Sweetening capacity of lactose. Otherwise, lactose can be used as a very good ingredient. Without milk, you can use lactose as a sweetening agent. Very good sweetening agent. Instead of sucrose, you can use lactose. Right? So, because of this sweetening capacity, lactose as a sugar, not as a milk, as a sugar, we can use as a coating agent. What is the coating agent? COAT. Coating agent. Because of the sweetening capacity of the lactose, you can use lactose as a coating agent. That coating means you can produce the food material, outer side of the material you can apply. So this agent is a coating agent. Our outside cover, right? Outside cover is a coating agent, coat, outer coat, right? So you can use lactose as a coating agent, right? In addition to the sweetening capacity of the lactose, it will give additional property because it can absorb so many flavors and colors. That is the additional property of lactose molecule. Lactose can add, right, so many flavors and colors. Therefore, that is very important in the food industry. If you need to apply any flavors, need to add any flavor to the, especially baby food like this, if you need add any permitted color to the food material, you can easily apply it with lactose coat. If you apply lactose coat outside the food, right, as a coating agent, lactose can readily absorb colors, flavors like compound. Right? So that is about the lactose. Right? Then we will think about few examples of oligosaccharide. So we have to complete anyhow oligosaccharide part within this session. Right? So when we categorize the compounds, right? When we categorize the compound, we categorize monosaccharide, disaccharide, then oligosaccharide and polysaccharide. Monosaccharide, disaccharide, then oligosaccharide and polysaccharide. Right? So if we come to the monosaccharide, one unit, one monomer, single monomer. Disaccharide, now we just completed part, that is two monomer units joined together like speaking. Oligosaccharide will be more than 2 units, but less than 10 units. Right? More than 2 units, but less than 10 units. That means in between 2 to 10. If the molecule contains 2 to 10 monomers, so those are known as oligosaccharides. Oligosaccharides. If the molecule contains the number of monomers available 2 to 10, so they are oligosaccharide. Oligosaccharide. Right? So most of the vegetable contains oligosaccharide, beans, cabbages, right? Like vegetables, right? Highly available oligosaccharide as their carbohydrate parts, right? So if I give the examples, this one is a raffinose. Name of this sugar is a raffinose. Raffinose consists of 3 monomers. These are 3 monomers, responsible monomers. Now you can observe the glycosidic one formation nature here. First component is the glucose. Second component is glucose again. But third component is the fructose. Right? First component is the glucose. Second component is the glucose. Third component is the fructose. Now you can observe the glycosidic linkage. First component all between 1 and 5. So 6. Here 1, 6 linkage. The second component 1, 4 linkage. This is trisaccharide or oligosaccharide. Raffinose, highly available in beans, sponge, and guava, cabbage. Right? This carbohydrate highly available in beans and cabbage like thing. Right? Interesting nature of this molecule. Now, can you say, anyone say, reducing and non-reducing property of this molecule? You can clearly check the molecule with your knowledge. Now you have enough knowledge to tell something about the reducing and non-reducing capacity of this molecule. Here, not 4, it is 4. What can you say about reducing or non-reducing capacity of this molecule? Here 1, 6, 1, 2. So if you think about up to this level, if it is only these 2 molecules, that is reduced. First carbon joined with the 6th carbon, but first carbon available. But that first carbon interact with the second carbon of the fructose. So whole molecule, if you try to check the availability of free anomeric carbon, see, no free anomeric carbon available in the molecule. All free anomeric carbon join with or engage with the bond. Engage with the bond. So no free anomeric carbon available in this system. No free anomeric carbon available means no reducing property. Therefore, they are non-reducing sugars. They are non-reducing sugars. They cannot increase your blood sugar level. They cannot increase your blood sugar level. Right? Sometimes you may think like this. Right? You may think like this. Although this is a non-reducing sugar, right? When people consume cabbage, beans like this, after digestion, they can convert into reducing. As a sucrose story, right? Sucrose story. Sucrose is initially non-reducing, but when you consume sucrose in the presence of invertase like enzymes, it will convert to fructose and sucrose, then reducing capacity is doubled. Right? That is the story behind the sucrose. But in case of raffinose like trisaccharide, story little bit different. Why? Invertase can break the glycosidic linkage between fructose and glucose of the sucrose. But here raffinose, there are different links, 1,6 link, 1,2 links, different links. Right? In sucrose, there is a 1,2 like type link. After here, molecule is a sucrose. But now you have another molecule. Therefore, invertase cannot completely digest the system. Right? Fortunately, your digestive system does not contain any enzyme to digest this. Fortunately, our digestive system does not contain any enzyme to digest this kind of polysaccharide. That's why people are advised to consume. People are suffering from diabetics-like condition are advised to consume oligosaccharides rather than monosaccharides and disaccharides. Because in most of the cases, our digestive system cannot digest oligosaccharides, right? Cannot digest oligosaccharides. So, but you can get an idea about the fullness of your stomach. That is very important item. Because if you start eating, if you continue eating, right? If it is, what is the end point? Sometimes no end point, right? Up to the vomiting point, you may eat, right? But if you consume more oligosaccharide like this, right, you cannot digest it. Although you eat, all are deposited within the stomach. Your stomach cannot digest it. Right? Therefore, gradually it will fill. Then there is a end point come, right, without high sugar content, right, with low carb content, right, low digestible carbohydrate content, you can end up with your major meal, right? So that is very important for that kind of patient, that diabetic patients, right? But sometimes there are certain microorganisms, they consume raffinose. They cannot release glucose to the body. They consume raffinose as a food, like lactose fermented one, right? And releases gases. Right? They release certain gases. Right? Therefore, when you consume considerable amount of this kind of food, you will feel like this large quantity of excess amount of gas within your stomach. Excess amount of gas within your stomach, right? Because of this nature. That means your intestine bacteria, microflora, consume this as a food. No harm to you. Right? No harm to you. Sometimes this is very important for them because they are known as probiotics. Probiotics, right? They consume this as a food and they produce certain vitamins, certain fatty acids, important fatty acids to us. Right? To produce them, they use these substrates. Therefore, instead of consuming high quantity of the carbohydrate, right? High quantity of the carbohydrate, this one is very important. Consumption, this kind of, right? Other important example is a strachios. I am going to draw the structure. Strachios. Strachios. Right? So likewise, there are certain trisaccharides containing 3 anomeric carbon, but most of the trisaccharide cannot digest within our system. We don't worry about that, right? We don't worry about that. So, this is the story behind disaccharide. Story behind disaccharide. So today in this session, so we discussed the important points like this. We started with the disaccharides, right? We discussed about the disaccharide, like formation of disaccharide. What are the responsible components of the disaccharides, right? Then we think about the reducing and non-reducing capacities of disaccharide. What is the responsible active one? That is free anomeric carbon, availability of free anomeric carbon. Then we discuss few examples of disaccharide. That is maltose, sucrose, lactose, like this. In addition to that, we explain trehalose, right? Then I draw the structures of all those things and explain the availability of free anomeric carbon. What is free anomeric carbon? Everything I explained in my first lectures. Right? Within the university, I explained. Right? Please go through those notes. Then you can get an idea about what is free anomeric carbon. Then one by one, I briefly explain what is maltose, what are the important points of maltose, right? Biochemistry behind the maltose like this, right? Then I explain sucrose, what is sucrose, what are the components of sucrose, what is the one type of sucrose, everything I explain, right? Then I explain inverse sugar with respect to sucrose. So we break the sucrose molecules into two components, that is glucose and fructose in the presence of invertase and hydrochloric acid, right? Then you have specific rotation type knowledge. I explain what is specific rotation based on the molecule and specific temperature and the rotation of the molecule, right? Then you can have idea about the specific rotation of those molecules. With respect to that knowledge, now you can explain inverse sugar concept, right? Inverse sugar concept, right? Then I come to the lactose-like disaccharide. Lactose-like disaccharide consists of galactose and glucose. Then I explain important point based on the lactose, that is reduced in sugar, not like trehalose like this. That is reduced in sugar. It contains free anomeric carbon because bond between glucose and galactose is 1,4 glycosidic link. Right? Then we think about the lactose intolerance condition available in the human being. When it starts with the infant stage, I explain it because of the deficiency of the certain enzymes required for digestion of the lactose. Right? So people suffering from that condition, they cannot consume fresh milk product because fresh milk product contain high amount of lactose because lactose is the major carbohydrates available in milk. Right? Therefore, they cannot consume lactose as a carbohydrate because their system cannot digest lactose. Right? But if they consume lactose, what will happen? I explained that one also. If they consume lactose, they cannot digest lactose, but there are certain microflora within their system and they use that one as a substrate and produce additional gas. That condition is known as flatulence. Right? That is dangerous for the kids, especially, right? The infant stage, but when they come to the adult stage, in addition to that, they will face certain allergic condition because of this lactose intolerance condition. They will face certain allergic condition because of this lactose intolerance condition. then that lactose intolerance condition may create certain rashes, certain sometimes aches, right? Skin diseases like this, right? That is lactose intolerance condition. So what do? You can convert lactose into lactic acid by fermentation. Lactose into lactic acid by fermentation. Then you can consume that kind of product. Lactose intolerance persons cannot consume lactose containing product otherwise. Right? Therefore, good products for them are curd, yogurt, cheese-like product. Right? Then I explained the sweetening capacity of lactose is very high, right? But compared to the sugar, but under fresh milk condition, you cannot feel that sweetening capacity. That's why we add small amount of sugar in. Sometimes you require small amount of sugar when you consume milk, right? The reason is sweetening capacity of lactose is mask that will cover. The word is mask. Mask will cover, right? Mask by it is masked by the casein. Casein is the major protein available in the milk. So once you once you remove the casein from the milk, then you can obtain the real taste of the lactose. The other important point of the lactose we discussed, that is, it is good sweetening agent in the food material. Along the lactose, that is the highly sweetening agent without milk, lactose without milk is sweetening capacity is very high. Therefore, you can use it as food ingredients as food ingredient sweetening agent. Right? Then other important point of the lactose, it can readily absorb colors and flavors. Therefore, you can use lactose as a coating agent of especially infant food. Infant food. Infant food means food for infants, not for us. Food for infants, right? Infant food, most probably they use attractive colors, attractive flavors like this, right? They use lactose coat before that because lactose coat readily absorb those colors and flavors. They use that property for their product, right? So with that, we can conclude that disaccharide part. Then we start the discussion of oligosaccharide. Not a very big discussion, right? We have several oligosaccharides that we know use like oligosaccharide. There are other more oligosaccharides. Oligosaccharide sources are beans, cabbages like this, right? So I explained one structure of the oligosaccharide. It took strateose chemical structure, right? With this structure, I explained two types of bond available, glycosidic linkage, 1,6 and 1,2 linkages. All the anomalic carbons engage with the bonds, glycosidic linkage. Therefore, most of the oligosaccharides are non-reducible, right? Not only that, we don't have the enzyme system to digest this kind of saccharide. Therefore, this is good source for our meat, right? With this kind of oligosaccharide, right? We cannot increase our GI. We will discuss it later. What is GI? Glycemic index. Glycemic index. We will discuss it later, right? Glycemic index should be very important point. Certain food can increase the glycemic index. That means the sugar is very high. Glycemic index it will increase rapidly, right? That is not good for the health, right? But raffinose like oligosaccharide cannot increase the glycemic index or GI, right? Therefore, this is good for our health, right? But there are certain microflora, probiotics available in your intestine. They can digest. They can digest the system, that is the strateose system, chain, and we can consume it as food substrate, and they will produce certain gases like lactose. But in addition to that, they will produce very important fatty acids, vitamins like this, right? Important fatty acids and vitamins like this. Therefore, rather than consumption of monosaccharides and disaccharides, consumption of this kind of carbohydrate is very important. Because when you consume starch, starch can digest by amylase. So final product is glucose. But if you consume this kind of thing, so our system cannot digest this system. Right? Therefore, we don't worry about increasement of sugar within our body. We don't worry about increasement of sugar within our body. Right? So that's the things we discuss within this lecture, right? With the next lecture, I am going to start new session regarding the polysaccharide, right? Up to that level, you have to go through the whole lecture, right? As usual, I am not going to give the notes like this, right? I think you can go through the lecture time to time. You can open. Now you have link. You can open time to time to wish, right? Then you can check. If you have any doubt, you can contact me. I think your payslip have the telephone number, right? Then through that line, you can contact me. If you have any questions, I think definitely once the university start, right? If you have any doubt, please questions, we can discuss again. Not all lecture. If you have any doubt question, we can discuss. Right? Up to that, you have to keep your own notes, right? Right? Safe in your house and learn more. You can go through the websites and everything. You can go through the internet and everything to learn more. Right? What are the disaccharide containing food? What are the monosaccharide containing food? What are the oligosaccharide containing foods? Right? Available sources, everything you can learn. Right? Now this is the guide. Lecturer is not a teacher. Lecturer is a guide. Right? It's a real guide. Right? That means I am guiding you for your future. I open the eyes for the future. Now you have to go. You have to go there. Right? You have to open new paths. Sometimes you can introduce new one to the world. You are the person sometimes. Right? You may introduce new form of the glucose molecule. Still we are discussing alpha form, beta form, like different types of form. You may introduce another form. Based on that, you can introduce different reactions. To do it, you have to critically analyze the system. Otherwise, you can't do it. Right? If you go through this lecture, if you hear this one, if you observe this one, if you note down everything, right? Then if you think, if I ask the same thing in the question paper, right? If you go through your notes, if you prepare like this, that is not the learning. That is not the learning. Right? You cannot learn anything from them. But with the help of this guide, you can learn a lot of things. Because remember, although now we are close, right? This is university. Although we are close, this is university. University will explore the world. Right? That is the duty of the university. Create new knowledge. Right? Not cramming. Right? Creativity is very important in the university, especially. So after this degree, sometimes most of the students try to go for their postgraduate. Right? In the postgraduate level, you have to improve this part, creativity part. Right? Those days, nowadays, we don't have teachers like this. Right? Nowadays, most of the teachers give everything for you. Slides, handouts, sometimes notes, e-books, so many sources. Right? You need not to worry about them. But real learning is not like that. Teacher must guide, student should go with the guide of the teacher. Right? If you have any questions at any point, then you can contact the teacher. Right? I have the doubt, I have a question. How do I solve this problem? Right? Can you help me like this? You can make a request. Right? Right. Okay. This lecture, I think this is enough for the first lecture. Lecture number 1. Based on this, in our next lecture, we will meet with polysaccharides. Right. Thank you.